Okay, so let us start. So, before talking about Minkowski space-time and all these things, I wanted to give a little bit of an introduction. So, most of these things you probably already know, but it's better that we discuss it and put everything into context. So, before I give you the postulates of STR, so STR did not just come out of the vacuum. There has been cause or sort of a search for certain ideas to resolve certain issues that physics was facing in the 19th century. And to understand those issues, first we need to look at what is known as the principle of relativity. Have you heard of the principle of relativity? प्रिंसिपल ऑफ रिलेटिविटी क्या है, आपने पढ़ा हुआ है? बेटा, हैव यू हर्ड ऑफ द प्रिंसिपल ऑफ रिलेटिविटी? Yes or no?
सर पोस्टुलेट्स के बारे में पढ़ा है, प्रिंसिपल का आई डोंट रिमेम्बर।
Okay, so principle of relativity was given by Galileo Galilei. Okay, it simply states that the physical laws are the same for all inertial observers. The physical laws, are the same in all inertial frames of reference. इसका मतलब ये है कि आपके पास जो भी फिजिकल लॉ है, इसका जो फॉर्म होगा, it is more or less the same. Like for example, you have two different persons. If you have two different persons, two different observers, let's suppose you have a person in S frame of reference and you have another person in S dash frame of reference. So one is given by, let's suppose, X, Y, Z, another frame of reference is given by X dash, Y dash, Z dash, such that the second observer is at some kind of a relative motion with respect to the first observer. So let's suppose the second observer is moving with a velocity v with respect to the first observer. So पहला जो observer है S frame में, it's like this blue observer, let's suppose, or S dash frame में, it is this orange observer. Okay, in such kind of a scenario, if both of them are observing a physical phenomena that is happening, then they will have to agree upon the law. Like उस टाइम पे जो गैलीलियो गैलीले न्यूटन के टाइम पे in the 17th century, the laws that existed were the laws of mechanics. तब तक इलेक्ट्रिसिटी मैग्नेटिज्म के ऊपर ज़्यादा रिसर्च हुआ नहीं था, इलेक्ट्रोमैग्नेटिज्म के ऊपर हुआ नहीं था, स्टैटिस्टिकल फिजिक्स के ऊपर हुआ नहीं था. मैकेनिकल लॉज के ऊपर न्यूटन ने इंट्रोड्यूस किया था, न्यूटन इन मैकेनिक्स, एफ इज इक्वल टू एम ए एट्सेट्रा एट्सेट्रा. ठीक है, तो ऐसे सिचुएशंस में जो फिजिकल लॉज है, वी मेंट बाय फिजिकल लॉज वी मेंट मैकेनिकल लॉज. ठीक है, तो इन दैट काइंड ऑफ अ सिचुएशन, अगर दो इंसान दो अलग अलग फ्रेम ऑफ रेफरेंस में हैं, तो लेट सपोज दे आर ऑब्जर्विंग सम काइंड ऑफ अ फिजिकल इवेंट पी कुछ भी हो सकता है. Maybe some ball drops at a particular location, maybe an explosion happens, maybe a light bulb switches on, whatever happens. So P can have various coordinates. It can have coordinates x, y, z, t with respect to the observer in the S frame of reference. And it can also have coordinates x dash, y dash, z dash, t dash with respect to the S dash frame of reference. ठीक है, now the transformation equations that connects x, y, z, t, which are the coordinates of the physical event with respect to the blue observer, and x dash, y dash, z dash, t dash, which are the coordinates of the same physical event with respect to the orange observer. This set of transformation equation is known as, in the pre-relativity era, it was known as what?
Galilean
So
Transformations.
Galilean transform.
Very good. These are known as the Galilean transformations. The Galilean transformation simply gives you a set of transformation equations to connect the coordinates of one physical event with respect to one observer to that of the coordinates of the same physical event with respect to another inertial observer in relative motion. So they are simply x dash is equal to x minus vt, y dash is equal to y, z dash is equal to z, and this was not this was implicitly assumed that the time flows at the same rate with respect to these things. Okay, now if you look under Galilean transformation, what happens is that you can we can talk about what is known as the principle of relativity is what is nothing but the Galilean invariance. Okay, if you look at how the Newton's second law transforms, so if you look at what is Galilean invariance, so what does the Galilean invariance tells us? It tells us that, let's suppose with respect to the S dash frame of reference, he is studying some kind of a physical event. Okay, he's looking at a physical event, and in that physical event he analyzing the motion, studying the motion, and he says that the particle in that physical event experiences some kind of a force F dash. Okay, now we all know that the Newton's second law is valid. All right, now both the observers will assume that the Newton's second law is valid, but can one observer equation lead to the other person's observer? Because only then we can say that they're consistent across the board. Okay, it has to be consistent across the board. Okay, it cannot necessarily be true only for each individual person, but it also has to be consistent across the board. So can we use the transformation equations to transform the Newton's second law itself? Okay, so let's suppose with respect to the observer in the S dash frame of reference, let's suppose whatever physical event he is studying has a force F dash, and the Newton's second law says that the rate of change of the momentum of that physical event is given by dp dash upon dt dash. This is the Newton's second law in the S dash frame of reference, right? With respect to S dash frame of reference. Okay, now if we look at this, what is this? This is nothing but, it can simply be written as, let's suppose we can take the mass out, and d upon dt dash of this is nothing but x dash. Okay, where x dash is nothing but x minus vt. Okay, so this is nothing but m upon dt dash, and dt dash को हम t लिख सकते हैं because t is equal to t dash, तो dt dash को हम t के टर्म्स पे लिख सकते हैं. Okay, so d upon dt, so d upon dt of x minus vt. So if I do this, it simply becomes m d upon dt. X minus vt is 1 dx minus dx upon dt minus v. Okay, अब यहाँ पे v क्या है? v is the relative velocity between both these two observers, which is a constant. It's not changing with time. Okay, the v is a constant. तो जब दोबारा से मैं डेरिवेटिव लूँगा तो ये क्या हो जाएगा? ये हो जाएगा m d2x अपॉन dt2. v हट गया, तो ये क्या हो गया? तो let's suppose mass is also invariant in this transformation. Mass does not change. m is equal to m dash. ठीक है, ये हम मान के चलते हैं कि जो मास है, जो टाइम का फ्लो है, दे रिमेन द कांस्टेंट. सो व्हाट इज दिस? दिस इज this can be basically written as d by dt of m dx upon dt, which is nothing but dp upon dt. Yes, this is the rate of change of momentum with respect to time with respect to the S frame. Yes or no? This is with respect to the blue observer, and according to the Newton's second law, this is nothing but the force experienced by the particle. So can you see that using the Newton's second law for one observer in the S dash frame of reference, I can reduce it to the Newton's second law with respect to the S frame of reference using the Galilean transformations. Can you see this? बेटा आपको दिख रहा है? Are you able to appreciate what I'm doing here?
Yes.
Yes, sir.
Using the Galilean transformations, what I have done is I've simply reduced the Newton's second law from the S dash frame of reference to the Newton's second law in the S frame of reference. Okay, using the Galilean transformations, nothing else. So it simply means that दो चीज़ें, एक तो Galilean invariance, which is nothing but the principle of relativity, which states that the physical law, which is the Newton's second law here, is the same for all inertial frame of reference, and the Galilean invariance, which simply means that I can transform the physical law expression from S frame of reference to S dash frame of reference, and vice versa, using the Galilean transformations. All right, so it simply means that the whatever the law is, the physical law, the mechanical law, both the person, this person as well as this person, they can agree upon the law and not only reduce each other's law from each other, they can use the Galilean transformations to compare each other's measurements. This is what's known as the principle of relativity or the Galilean transformations. Now this was a well-known, well-established idea for a long time before some other things happened. क्या हुआ? What happened in the next 200 years? So what I have demonstrated here is that आपके पास जो भी लॉ है F इज इक्वल टू एम ए, और यहाँ पे आपके पास लॉ है F डैश इज इक्वल टू एम ए डैश, तो यू कैन ट्रांसफॉर्म बिटवीन दम using the Galilean transformations. Okay, this is what I've established. Now, in the next 200 years, what happened was the development of another field of study known as electromagnetism. इलेक्ट्रोमैग्नेटिज्म तो पता है ना, आप लोग तो पढ़ रहे हैं. What are the fundamental equations in electromagnetism called known as? What are the fundamental equations in electromagnetism known as?
Maxwell's equation.
Maxwell's equations, very good. The fundamental equations in electromagnetism are the Maxwell's equations. जिस तरह से मोशन में वन ऑफ द फंडामेंटल इक्वेशन इज दैट ऑफ द न्यूटन सेकेंड लॉ, या फिर आप अगर लैग्रांजियन फॉर्मुलेशन को भी देखते तो इट्स इक्विवेलेंट टू न्यूटन सेकेंड लॉ. ओके, इवन इफ यू टॉक अबाउट द लैग्रांजियन फॉर्मुलेशन, इक्विवेलेंट टू द सेकेंड लॉ. And in electromagnetism, however, by the contribution of many people who studied electricity, charges, magnetism, etc., they were all correlated to each other fundamentally by the equations provided by Maxwell, which are known as the Maxwell's equations. Now, if you look at the Maxwell's equations in vacuum, अगर मैं Maxwell's equations को लिखता हूँ in vacuum, then they are del dot E is equal to 0, del dot B is equal to 0, del cross E is equal to minus del B upon del T, and del cross B is equal to 1 upon C square del E upon del T. These are the Maxwell's equations in vacuum, right? वैक्यूम मतलब देयर इज नो चार्जेस प्रेजेंट, इसलिए मैंने ऊपर 0 लिखा है.
Yes, sir.
Now, I want to come up with two conclusions from here. I have talked about the Galilean invariance, principle of relativity. इसको मैं थोड़ा pause पे रखता हूँ because I need to correlate with whatever conclusion I made here to something else. And to do that, I'll discuss a little bit of a discussion on Maxwell's equations in vacuum. Two conclusions. The first conclusion is existence of electromagnetic waves. Electromagnetic oscillations. Now, it can be very easily deduced from the Maxwell's equations that some kind of a electromagnetic oscillations और waves are predicted by the equation. So आप इसको देख सकते हैं. So for example, if you look at मैं इसको derive भी कर सकता हूँ. अगर मैं curl of जो E है मेरे पास, ठीक है, जो कर्ल ऑफ ई है उसका मैं एक और कर्ल ले लेता हूँ. सो दिस इज नथिंग बट कर्ल ऑफ, अच्छा यहाँ पे एक -1/c² आएगा क्या? नहीं आएगा. सो डेल क्रॉस minus dB upon dt. So this is equal to minus इसको we can the time space derivative and the time order derivative. So here this I can write as del cross b. So del cross b को I can write as del by del t of del cross b को 1/c² del E upon del T. So this is equal to -1/c² del 2E upon del T2. Okay, now यहाँ पे of course c² नहीं था, it was nothing but I think root over, it was mu naught epsilon naught, right? वो c² हम बाद में put कर देंगे. तो from here what is the general expression for the curl of some vector field? आपको याद होगा ना, कर्ल ऑफ ए वेक्टर फील्ड कैन बी रिटन एज द ग्रेडियंट ऑफ द डाइवर्जेंस ऑफ ए वेक्टर फील्ड माइनस del square A. हाँ, दिस इज करेक्ट राइट. तो इसको मैं यहाँ पे लिख सकता हूँ del डॉट E माइनस del square E. तो यहाँ पे del डॉट E तो 0 है. So therefore this comes out to be minus del square E is equal to -1/c² upon del t². So finally what you get is you end up getting or del square E t² minus c² is equal to 0. Okay, this is one equation. Similarly you can also prove, मैंने यहाँ पे इलेक्ट्रिक फील्ड के साथ किया है ना, तो मैं उसी तरह से I can also prove similarly you can also prove that del square b upon del t² minus c² square b is equal to 0. ये इक्वेशन भी आप प्रूव कर सकते हैं in the same exact same fashion. Now what is this equation? What are these two equations, beta?
Wave equation.
These are waves of what? Waves of what?
Electric or magnetic field.
So this is a wave equation of the electric field, and this is a wave equation of the magnetic field. Now usually क्या होता है जब आप wave equation लिखते हैं, आपका ये wave equation का फॉर्म यूजुअली होता है let's suppose d2y upon dt2 minus v² d2 let's suppose y upon dx² is equal to 0, something like this, जहाँ पे y जो represent करता है आपका y amplitude होता है, something like that. Okay, now what is the amplitude? Let's suppose कोई string है, वो string का कितना height होगा at any given point in time, या फिर कोई ripple on a pond है तो उस molecule का या उस point का कितना height होगा. It basically represents amplitude. तो here what is happening is that it is the electric field line or electric field vector that is undergoing So these oscillations going up and down and up and down and up and down, and with respect to this, it is a magnetic field vector that is also going up and down, up and down. If you do a little bit of a proper analysis, you can draw a kind of a diagram that looks something like this. Okay, बना देता हूँ. This is one. So these arrows simply represent, let's suppose, the electric field vector lines. Okay, the field lines. These field lines with time and space, they are sort of increasing and then decreasing and then increasing and then decreasing. They are positive and then negative. So with respect to space and time, just like a ripple in a pond, जैसे pond में क्या होता है, ripple क्या होता है, with time and space वो ऊपर जाता है, फिर नीचे आता है, फिर ऊपर जाता है, फिर नीचे आता है. Just like the amplitude of a ripple in a pond, these electric field lines are also going something like this, let's suppose. And there are magnetic field lines also associated with it, let's suppose, like this. And they are also going, the magnetic fields are also oscillating in the same sort of a phase. Without going too much into detail, आप लोग तो पढ़ ही रहे हैं ना थर्ड ईयर में, ये सारा कुछ बहुत डिटेल में पढ़ रहे हैं. मैं बस इतना ही कहना चाहूँगा that the Maxwell's equations predicted the existence of electromagnetic oscillations traveling at the velocity of light. So C is equal to 292,792,458 meters per second. Okay, in vacuum, these the theoretical foundation of electromagnetism, which are the Maxwell's equations, they predicted the existence of these electromagnetic oscillations. The Maxwell's equations predicted the existence of electromagnetic oscillations in vacuum. The Maxwell's equations predicted the existence of electromagnetic oscillations in vacuum. So this is the first point that I would like to make. Now, without going too much into detail, one very obvious question arises when you talk about waves, because तब तक लोगों ने जितना waves के बारे में study किया था, every wave, let's suppose whether it is a sound wave or whether it is a waves on the pond or whether it is waves on some kind of a string, they all had some kind of a medium associated with it. So one question that arose was that what is the medium of this wave? That is the first question that arose, and people started predicting that maybe there is something called ether, and फिर ether है या नहीं है, फिर ether के रेस्पेक्ट में क्या वेलोसिटी है लाइट की, अर्थ की क्या वेलोसिटी है विद रेस्पेक्ट टू ether, और उस चीज़ को प्रूव करने के लिए कौन सा एक्सपेरिमेंट परफॉर्म किया गया? Which experiment? Michelson Morley experiment. So we'll not go detail into this. So Michelson Morley experiment was performed to see what is the velocity of Earth with respect to the ether, which is supposed to be the absolute frame of reference of this electromagnetic oscillation. So this is the first point that I'm making, and the second point. Let's come to the second point. The second point is that एक तो it predicted the existence of electromagnetic oscillations, and second of all, not invariant with respect to Galilean transformations. Not invariant with respect to Galilean transformations. यहाँ पे मैंने principle of relativity बताया थोड़ी देर पहले आपको. I said that the physical laws are the same in inertial frames of reference. Now, principle of relativity came before all these things. Okay, Newtonian era में आया था, जब सिर्फ mechanical laws के बारे में मालूम था. And I showed the Galilean invariance also. F is equal to ma under Galilean transformations becomes f dash is equal to ma dash, right? However, a similar kind of a calculation. Let's suppose if I say that del dot E is equal to 0, del dot B in vacuum is equal to 0. Let me write down del cross E is equal to minus del P upon del T. These are the Maxwell's equations in vacuum. And del cross B is equal to 1 upon C square del E upon del T. This is with respect to, let's suppose, the S frame. Okay, now with respect to the S dash frame, if I can write that del dash dot E dash, so these are with respect to the S dash frame, and if I can write del dash dot B dash is equal to 0, and I can write del dash cross E dash is equal to minus del B upon dash upon del T, and I can write del dash with cross B dash is equal to 1 upon C square del E dash upon del T dash. Okay, with respect to the S dash frame. तो मैं अगर मानता हूँ that with respect to one person the Maxwell's equations are correct with respect to S dash frame, and ये भी मान के चलता हूँ with respect to another inertial observer the Maxwell's equations are correct. However, I will not be able to show that there is a consistency of these equations connected by the Galilean transformations. Are you understanding what I'm saying? जिस तरह से मैंने यहाँ पे आपको दिखाया कि the Newton's second law easily transforms under the Galilean transformations into a new form with respect to another observer. The Maxwell's equations do not transform under the Galilean transformations by retaining its form with respect to another observer. Are you understanding?
Yes, sir.
So it simply means that what I'm trying to say is that Maxwell's equations are not invariant. मतलब their form does not remain invariant under Galilean transformations. तो इसका मतलब क्या है? इसका मतलब ये है कि या तो ये करेक्ट है और ये रॉन्ग है, या फिर ये करेक्ट है और ये रॉन्ग है, या फिर ये दोनों करेक्ट है लेकिन Galilean transformations is wrong. Now I'm skipping a lot of discussion here of course, क्योंकि ये जो derivation है बहुत ही लंबा है. इनफैक्ट मैंने इसके ऊपर एक वीडियो बना करके अपने चैनल पे अपलोड किया. इफ़ यू आर इंटरेस्टेड यू कैन चेक दैट आउट. तुम्हारे सिलेबस में नहीं है तो मैं इसमें डिटेल में नहीं जाऊँगा. बट देयर इज़ अ वेरी सिंपल डेराइवेशन टू शो दैट इफ़ आई स्टार्ट विद दिस आई कैन नॉट प्रूव दिस अंडर Galilean transformation. If I start with this I cannot prove this under Galilean transformations. Are you understanding what I'm saying?
Yes, sir.
Okay. Two problems. First, there was the existence of electromagnetic oscillations. Second, existence of electromagnetic oscillations. उसमें लोगों ने पूछा कि मीडियम क्या है. They predicted ether. फिर माइकलसन-मॉर्ली एक्सपेरिमेंट परफॉर्म किया and there was a null result. They could not prove the existence of ether. In fact, the only logical conclusion was that velocity of light is a constant. Velocity of light is a constant. ये आपको याद है ना, या बताने की ज़रूरत है? ये जो वेलोसिटी ऑफ लाइट इज अ कांस्टेंट है, ये कंक्लूजन आपको याद है ना, या फिर बताने की ज़रूरत है?
Yes, sir, याद है.
हाँ, माइकलसन-मॉर्ली में अर्थ इस तरफ जा रहा था तो दे वर ट्राइंग टू फाइंड आउट द वेलोसिटी ऑफ लाइट इन टू डिफरेंट डायरेक्शंस. एक डायरेक्शन में c माइनस वी होता, दूसरे में c होता. तो दे वर ट्राइंग टू फाइंड द डिफरेंस बिटवीन दीज टू वेलोसिटीज. They were unable to do that, and the only logical conclusion was that the velocity in both these two directions was same. That is one conclusion of the Michelson-Morley experiment. दूसरा, that the Maxwell's equations remain not invariant under the Galilean transformations. So इसका मतलब क्या है? क्या इसका मतलब ये है कि क्या फिजिकल प्रिंसिपल ऑफ रिलेटिविटी इज रॉन्ग, that the physical laws are not the same in all inertial frame of reference? Because if this is true, then the physical relativity is wrong. So Einstein came into the picture without going too much into detail. It's a long history. It's a very long history. Einstein came into the picture and he said that सबसे पहले तो जो ये transformation है, it is absolutely correct. It's just that the transformation equations that we are writing, they are incorrect. This is incorrect. There is some other transformation equation here that we need to find out. जिसमें ये जो principle of relativity है, it will be consistent. He said the principle of relativity is correct, not just for the mechanical laws, but also for the electromagnetic laws, which is the Maxwell's equations. But it is the Galilean transformations which is wrong. And we must find out a new set of transformation equations, जिसमें ये जो है invariance रहेगा. मतलब Maxwell's equations are not invariant in a GT, but under the new transformation equations it will be invariant. दूसरा, velocity of light जो ये constant है, it is some kind of a Einstein figured there is some kind of a law of the universe that it's a universal constant, and based on this he gave what is known as the special theory of relativity. It's just two postulates, and the two postulates will resolve all of these issues. He gave what is known as the special theory of relativity. Okay, so tell me, what are the postulates of the special theory of relativity? What are the postulates of the special theory of relativity, beta? Come on. What are the postulates of the special theory of relativity? क्या हुआ? ये तो नहीं बोल सकते.
Velocity of light remains same in all inertial frame.
Second postulate. What is the first postulate?
So the
Law of
principle of
Maxwell.
relativity is the first postulate.
Yes. But instead, earlier the principle of relativity only included mechanical laws. Now it includes all laws, electromagnetic laws, statistical laws, thermal laws, whatever it is. The first postulate is the principle of relativity. Which says that the laws of physics are the same in all inertial frames of reference. That's it. And the second is the, as you said, constancy of the speed of light. Speed of light is not just some ordinary velocity. It is a universal constant. The velocity of light in empty space is same in all inertial frames. The velocity of light in empty space is same in all inertial frames and is independent of the motion of the source. Okay, so first is the principle of relativity जो हमने पहले डिस्कस किया था, but now he included the all laws of physics, whatever it is, the mechanical laws, the statistical laws, the thermal laws, the electromagnetic laws, all laws of physics are invariant और आर द सेम इन ऑल इनर्शियल फ्रेम्स ऑफ रेफरेंस। तो अगर मैंने जिस तरह से यहाँ पे मैक्सवेल्स इक्वेशंस लिखा है, मैं किसी दूसरे डोमेन में भी लिख दूँ तो वो जो है आई कैन गो फ्रॉम एन एस फ्रेम ऑफ रेफरेंस टू एन एस डैश फ्रेम ऑफ रेफरेंस एंड दे आर इनवेरिएंट एज यू गो फ्रॉम वन फ्रेम ऑफ रेफरेंस टू अनदर। तो यहाँ इसके बीच का जो ट्रांसफॉर्मेशन इक्वेशन है वो क्या है, दैट इज समथिंग दैट वी नीड टू फिगर आउट. And the second is a constancy at the speed of light, which basically tells that the speed of light is what Michelson model experiment में जो conclusion निकला, that speed of light is a constant with respect to two different relative motions. So therefore speed of light is a constant for all inertial frames of reference, चाहे उनके बीच में कोई velocity है नहीं है. Like for example, अगर आप किसी गाड़ी में जा रहे हैं और गाड़ी के अंदर जो है कोई पर्टिकुलर एक मीडियम है, ठीक है, उस मीडियम में अगर साउंड वेव है, साउंड वेव की वेलोसिटी अगर लेट्स सपोज v1 है और उस गाड़ी की वेलोसिटी v2 है, तो आप अगर बाहर है तो आपके रेस्पेक्ट में साउंड वेव की वेलोसिटी कितनी होगी? अगर गाड़ी है, गाड़ी के अंदर मीडियम में कोई साउंड वेव जा रहा है और गाड़ी के रेस्पेक्ट में उसकी वेलोसिटी v1 है, लेकिन वो गाड़ी v2 स्पीड में आपके रेस्पेक्ट में जा रहा है, तो आपके रेस्पेक्ट में उस साउंड वेव की वेलोसिटी कितनी होगी? कितनी होगी?
v1 प्लस v2.
v1 प्लस v2, वेरी गुड. लेकिन व्हाट आइंस्टाइन इज सेइंग दैट अगर एक गाड़ी है और उस गाड़ी में एक लाइट वेव है, जो लाइट वेव की स्पीड c है और वो गाड़ी v2 स्पीड में जा रहा है, तो आपके रेस्पेक्ट में उस लाइट की वेलोसिटी कितनी होगी? c ही होगी. दैट्स इट. सो दिस इज नॉट समथिंग वेरी ऑब्वियस. ओके, ये कोई कॉमन चीज़ नहीं है. ये बेसिकली जो हम वेलोसिटी एडिशन यूज़ करते हैं ना, उसको हटा दिया कम्प्लीटली. ठीक है, जो नॉर्मल साउंड वेव्स के साथ, रिपल्स के साथ, कोई भी तरीके का वेव के साथ हम वेलोसिटी एडिशन करते हैं, वो कम्प्लीटली हटा दिया है. लाइट आपके रेस्पेक्ट में आगे जा रही है किसी मीडियम में या पीछे जा रही है, डजेंट मैटर. लाइट का स्पीड जो है हमेशा c ही होगा इन वैक्यूम. मीडियम में ऑफ कोर्स c नहीं होता, बट इन वैक्यूम वो हमेशा c ही होगा. सो ही सेड दैट ये वेलोसिटी एडिशन सब्ट्रैक्शन जो हम करते हैं रिलेटिव ऑब्जर्वर्स के रेस्पेक्ट में, वो कम्प्लीटली इट्स नॉट ट्रू, बिकॉज इट्स अ कॉन्स्टेंट ऑफ स्पीड ऑफ द यूनिवर्स. देयर सम वेरी स्पेशल इंपॉर्टेंस. ओके, so these are two very important things. Now using these, एक तो principle of relativity, दूसरा constancy of the speed of light, we can come up with what is this missing link, the missing link in the picture, जिसको यूज़ करके कोई भी सेट ऑफ लॉस को एक फ्रेम ऑफ रेफरेंस से दूसरे में इन्वेरिएंट प्रूव किया जा सकता है. वो क्या है, उसको डिराइव कर सकते हैं यूजिंग प्रिंसिपल ऑफ रिलेटिविटी एंड कॉन्स्टेंसी ऑफ स्पीड ऑफ लाइट. आपने मुझे बताया कि आपने लॉरेंस ट्रांसफॉर्मेशन का डिराइवेशन किया है. डिराइवेशन क्या है, मुझे करने की ज़रूरत नहीं है. डिराइवेशन किया है ना लॉरेंस ट्रांसफॉर्मेशन का? हाँ, इट्स नॉट दैट डिफिकल्ट. ओके, सो आई एक्चुअली डिड द लॉरेंस ट्रांसफॉर्मेशन डिराइवेशन विद द फर्स्ट ईयर. वो भी मैकेनिक्स पढ़ा रहा था मैं उनको. सो आई डिड द डिराइवेशन. सो इफ यू आर इंटरेस्टेड यू कैन चेक दैट आल्सो. सो यूजिंग दीज टू पोस्टुलेट्स, यूजिंग द टू पोस्टुलेट्स of STR, we can find out a new set of transformation equations, between two inertial observers in relative motion. तो जिस सेम सिनेरियो जो है पहले कि लेट्स सपोज एस फ्रेम ऑफ रेफरेंस है, एस डैश फ्रेम ऑफ रेफरेंस है, एक्स वाई जेड, एक्स डैश वाई डैश जेड डैश ओ डैश एस फ्रेम. So you have an S frame of reference and you have an S dash frame of reference such that they are rectangular Cartesian coordinate frames of reference such that x-axis is parallel to the x-dash axis, y-axis is parallel to the y-dash axis, z-axis is parallel to the z-dash axis, and at time t is equal to 0, both the origins coincide, but after some time the s-dash frame of reference move ahead because it is traveling with a relative velocity v along the x-dash axis. This is the construction. अगर ऐसा situation है तो both the postulates को use करके I can prove that the transformation that exists between a physical event which is given by x, y, z, t and x dash, y dash, z dash, t dash, मैं यहाँ पे एक ट्रांसफॉर्मेशन इक्वेशन ऑब्टेन कर सकता हूँ x, y, z, t जो है आपका एंड x डैश, y डैश, z डैश, t डैश जो है आपका, उसके लिए मैं अगर एक कोई ट्रांसफॉर्मेशन इक्वेशन फाइंड आउट कर रहा हूँ तो आई नीड ट्रांसफॉर्मेशन इक्वेशंस that are consistent with the two postulates of relativity, that are consistent with the two postulates of relativity. तो उस ट्रांसफॉर्मेशन इक्वेशन को बोलते हैं LT, लॉरेंस ट्रांसफॉर्मेशंस. Lorentz transformations, and I'll just straight away write what is the form of these transformation equations. X dash is equal to gamma x minus vt, y dash is equal to y, z dash is equal to z, and t dash is equal to gamma t minus vx upon c square, where gamma is equal to 1 upon root over 1 minus v square upon c square. These are the transformation equations between x, y, z and x dash, y dash, z dash. You can also find out the inverse transformation equations. The inverse transformations is just when you go from s dash to s frame. So that is x is equal to gamma x dash plus v t dash, and y is equal to y dash, z is equal to z dash, and t is equal to gamma t dash plus vx dash upon c square, where gamma has the same meaning. Okay, these are your transformation equations that satisfy the two postulates of STR. Is it clear?
Yes, sir.
Yes, sir.
Okay. Now I can use these transformation equations to prove many things, but I think लॉरेंस ट्रांसफॉर्मेशन से आपने लेंथ कॉन्ट्रैक्शन टाइम डायलेशन को ऑब्टेन किया है.
Yes, sir.
Okay, fine. So I don't want to repeat anything that you have already studied. So what I need to do is, maybe we'll talk about length contraction, time dilation and velocity transformation once using the Lorentz transformations, just so that it's kind of a revision. उसके बाद we will do space time, because अब क्या हो गया, पहले क्या था, पहले जो था आपके पास x dash, y dash, z dash ही हम कोऑर्डिनेट्स मानते थे, टाइम को अलग कोऑर्डिनेट नहीं मानते थे. अब क्या हो गया, टाइम भी रिलेटिव हो गया ना. तो नाउ वी नीड टू कंस्ट्रक्ट. तो यहाँ पे आपने देखा होगा कि मैंने क्या कंस्ट्रक्ट किया, एक कोऑर्डिनेट फ्रेम ऑफ रेफरेंस कंस्ट्रक्ट किया यूजिंग एक्स डैश, वाई डैश एंड जेड डैश. टी डैश तो है ही नहीं यहाँ पे, मैं इक्वेशन में टी डैश लिख रहा हूँ, लेकिन मैं ड्राइंग में तो 3 ही कोऑर्डिनेट है मेरे पास. तो अब जो ज्योमेट्री है स्पेस की वो था एक्स वाई जेड, लेकिन अब जो है टाइम भी जो है तुम्हारे रिलेटिव मोशन के ऊपर टाइम भी डिपेंड करता है. टाइम इज़ नॉट सेम फॉर एवरीबॉडी. टाइम का जो कोऑर्डिनेट मेरे लिए होगा और आपके लिए होगा वो अलग अलग होगा अगर आप किसी बहुत ही हाई वेलोसिटी के साथ मूव कर रहे हो. तो नाउ अ न्यू ज्योमेट्री ऑफ स्पेस टाइम नीड्स टू बी क्रिएटेड विच इज़ द मेन कॉज की स्पेस टाइम. तो वो हम नेक्स्ट क्लास में डिस्कस करेंगे. ठीक है, थोड़ा सा डिटेल में डिस्कस करना पड़ेगा.